welcome to Conversations with Change Extremes. I'm Neil Maxwell, the founder of Change Extremes, co-founder of Change Extremes. We're focused on reducing our use and reliance of plastic within the construction industry. And these series of conversations have been created to give an insight into the issues of plastic that we have around the marketplace, and some alternatives that are being introduced, and just general discussion.
We just lost your visual, so we lost your camera for a second.
Sorry about that. So it's just really sort of getting different voices from different perspectives to talk about this subject and explore the options that are available. So thank you for joining us anyway today. First thing I'll do is, you know who I am now, so I'm going to go around table and ask everybody to do some introductions. So Addy, I'll start with you if I may, please.
Thanks, Neil, and thanks for the overview again. So my name is Addy, and I'm a chartered engineer and researcher based at Brunel University, London. My background is in engineering, so I did a degree in engineering at Liverpool and my PhD at Lancaster. And over the past few years, my research has been focused on manufacturing processes and more importantly, characterizing the properties of different materials. And my recent project was on engineered wood products. And more recently at Brunel, I'm focused on additive manufacturing. So that's a quick overview, but I'm looking forward to talking better.
Thank you, Addy. Duncan, may I hand over to you, please?
Yeah, hello. My name's Duncan Baker-Brown. I teach research and practice around sustainable design, and the rumbling is a train going past, actually, because my office is on top of a railway station. But yeah, I've been doing it for quite a long time. I've spent a lot of time looking at how to reduce the embodied carbon and the overall impact of buildings. And so I've looked at strategies for employing buildings that are locally sourced, materials that are locally sourced, organic, and in many cases, an alternative to plastic. Actually, in 1994, the first project I did, which was called the RIBA House of the Future, we had a plastic-free kitchen. It was a Greenpeace-sponsored kitchen. But I've worked with round earth, all sorts of organic insulation products. And in 2017, I wrote a book called The Reuse Atlas with the RIBA, subtitled The Designer's Guide Towards a Circular Economy. That book reflected on the fact that for about 20 years, I've been using locally sourced organic materials in all sorts of building typologies. But then it felt like behind me, this big pile of waste of non-organic stuff had formed. And so we challenged ourselves to use that as a source material to create a building that performed at Passive House standards. So that was the Waste House, which was built in 2014 by students, performs at Passive House standards, and basically became a vessel collecting products without an end-of-life strategy. So that's why I've been focusing on the circular economy closed-loop strategies to make sure that everything we design has an end-of-life strategy that doesn't mean floating in the oceans.
Brilliant. Thank you. Thanks, Duncan. That's a great overview. Tom, would you like to give a little bit of an insight about your background, please?
Yeah. Thanks, Neil, by all means. Yeah, very excited to be here today. Nice to meet everyone. I'm Thomas Bennett, so I'm a research fellow here within the Sustainable Materials Innovation Hub, which is based at the University of Manchester. So we're within the Henry Royce Institute here in Manchester, and it's a project that's funded by the European, well, part funded by the university and part funded by an organization called the European Regional Development Fund. So they basically, although it's phasing out with Brexit, it was a scheme that was designed to promote growth and innovation in specific regions across Europe. So this project is for Manchester itself. And the idea, we're a small team here of around 10 people. We've got a few industrial liaisons. Our director is Professor Michael Shaver. There's another research fellow on board and a couple of technicians and other support staff. And the idea of this project is to specifically help the small to medium enterprises in Greater Manchester with their sustainability challenges that they're facing in their businesses, because a lot of the time these small organizations, they're firefighting all the time. They have a lot of things going on. They don't really have the resources that these big organizations do to tackle sustainability issues. Plastics is a big one of those, of course. So the idea of this project is to provide that support and help them along on their sustainability journey. So yeah, that's my background is a PhD in polymer chemistry originally, and since then I've worked on various industry and academic projects based within universities most of the time. I just finished a KTP project before joining this role, which was joint with a company in Scotland called Superglass Insulation that makes glass fiber insulation for the construction industry primarily. So that's kind of my more direct experience, part of the reason I signed up for today. But yeah, looking forward to a very engaging discussion.
Brilliant. Thank you, Tom. That was great. David, I of course know all about you because we've been on a recent webinar together. So yeah, please carry away and introduce yourself.
Hi everyone. I'm obviously not quite so distinguished as my fellow guests here, but for about 25 years now we've been growers and producers of Miscanthus, otherwise known as elephant grass or UK tolerant sugarcane. It's the second highest yielding biomass, second to bamboo, so and obviously it's non-invasive. Traditionally we've used this crop as an energy crop for carbon zero energy, but I think it's far too valuable as an ingredient into the sustainability materials market. And so about a year ago we started playing around with a pulping process that would be farmer friendly or certainly rural friendly. And we've been working with Exeter University on carbon negative concrete, which we've called Miscrete. And currently we've got an LCA on that at about 130 kg of CO2e minus per cube. So that's been quite successful. It's not structural as yet, but we're hoping to get there. And we've also been working on fiberboard for office furniture and other bits and bobs like that. So we're also doing a lot of work with, or doing some work with Bristol University on various celluloses, and the ability to create cellulose foam as well is one of the projects that we've got hopefully in the offing. So that's a little bit about us.
Brilliant. Thank you, David. You undersell yourself. Honestly, you're doing amazing stuff. You really are. Hamish, welcome, and thank you for joining us at such late notice. I know we've spoken a few times in the past, but it's great to have you here. And so please carry on and give everyone a background of where you're coming.
I definitely think that I would be overselling myself, whatever I say, in this distinguished company. A little bit about me. I would say I'm in the business of sustainability, or in the sustainability of business, working as an international strategic consultant with mainly food and beverage companies doing sustainable supply chains. But I've also recently been working with a rather large petrochemicals organization involved heavily in the production of monomers for polymer manufacture and of course usage in construction industry and utilities. I'm also the group manager of the Sustainability Professionals group on LinkedIn, which has got 271,000 members. So I get a lot of rubbish coming through to sort through, but a lot of very good stuff in amongst that as well. What I'd also say is I've done some LCA stuff recently. The beginning of the year, we did some work on bamboo construction mats against oak construction mats for use in the oil pipeline industry across in Canada. So limited exposure, happy to be here today. Look forward to an interesting conversation.
Brilliant. Thank you, Hamish. And last but not least, one of my colleagues in Change Streams, Leo, if you'd like to give a quick. Leo's joined me today just to explain. Brendan's had to drop out at late notice because he's not very well. So Leo and myself have jumped in to host this event, hence why we're doing it. So Leo, just let you do a quick introduction.
Thanks, Neil. Thank you, and thanks to everybody for joining this morning, this afternoon, rather, to our webinar. It's just really a very brief overview for myself. My background is probably 30 odd years in marketing and business development, working within the construction sector, often with building materials manufacturers. And about 2006, I stepped out of that and set up my own business consultancy, which was focused on business strategy, marketing, and now on coaching and development. But I work with a lot of clients, ironically, who have a lot of plastic in their building materials. So that'll be that insulation, be it obviously membranes, be it XPS and various other materials as well. And so working with Neil and the team at Changing Streams, there's a real passion to actually sort of do things differently and to improve what we do, and plastic is obviously a part of that process. So from a marketing perspective, I hear a lot about sustainability. I hear a lot about green building, and again, it's a question of really what we can do to actually sort of drive that. So what I'm interested in is obviously what we can do in terms of driving change, real change, and not from a marketing perspective, just greenwashing, if we can put it in those terms. So that's my background. Thank you.
Brilliant. Thank you, Leo. So great. Thanks everyone for the introductions. That's great. Now to the heart of what we're going to talk about today. So the theme today is sustainable alternative to plastic materials used in construction. So to give a bit of an overview on that. We know plastics are used extensively in construction. It's the second largest user of plastic after the packaging industry, generating around about 50,000 tonnes of plastic packaging waste every year. We also know there's about 380 million tonnes of plastic produced every year. 20% of that is used in construction. So it's used extensively. We understand and we know the impacts that it's causing to the environment and to marine life, and we're only just really starting to understand the impacts that it's having to human life as well. We are not here to make this clear. We're not here to demonize plastic, because I've been called out on that a few times. We're not about demonizing plastics. We're actually sort of, what we aim to do is we're trying to turn the plastic tap down, because in our opinion, you won't achieve your carbon goals if you don't bring the plastic question into the equation, because it takes more amounts of, well, probably 3-to-1 ratio carbon to plastic. So three kilos of carbon to produce 1 kilo of plastic in roundabout figures, depending on what you're doing. So it's fossil fuel intensive. So we really believe that you've got to bring the plastic question into that equation. We need to understand, we're looking at sort of alternative materials. We want to understand what the barriers are. We want to understand what, you know, where are these coming through, and what are the, you know, what are the options, and what are the new inventions and ideas and solutions that are coming through now that we can utilize in construction. So the question for the panel is, where do you see new materials being used, and what, you know, how what are the restrictions in those new materials? I mean, there's obviously some quick wins, but I'd like to understand from the panel here where those new materials are coming through, and how we can use them, and how we can swap out. Are the changes that easy? What are the difficulties? So Duncan, yeah.
Wait, so I'm going to start with my what I think is the most interesting point. So I might have to leave the meeting early because I peak early. But no, I'm doing a lot of work with a company who are actually a bunch of Brunel students, and they form a company called Biome. So Biome, and they're producing mycelium products. So this is mushroom roots and fungi. So they're about to get a BBA certificate for a product that's insulation, and it has better fire rating than normal plastic insulation, so that's useful. And the product that we're looking at has the same R value, resistance value, to to polyurethane insulations out there. So it's going to also be marketed at the same price. So that's very interesting to me, because that's a product with an end-of-life strategy. It will compost if you put it in the ground. And so we've literally got 2 or 3 buildings detailed up, waiting for that BBA certificate to happen. So we'll omit what we've got in there and add that. That's a game changer. I think Mycelium products could be a game changer. And I know there's numerous countries around the world looking at that. If you get a Dell computer at the moment, the packaging of a Dell computer is cardboard plus Mycelium. So, and you might not have even noticed it, because the Mycelium element just does look a bit like a strange looking polystyrene for the packaging. The other interesting thing is, I know that one of the streams of Mycelium that Biome and other companies are looking at actually grows by consuming plastic. So at the moment it takes 4 years to do it, so that's just too long. But a few years ago it took 8 years. So one day you could imagine the sort, a factory producing Mycelium insulation where the food stuff is waste plastic. I mean, that's for me, that's very exciting. And I've known about, as a lot of people have, I guess, about Mycelium for a long time. But for me, it's actually, for the last 25 years, the insulation component of the building's been where we've been most innovative, using natural materials, where it's hemp, flax, sheep's wool, timber fiber, whatever it's, we had recycled cotton and hemp for a few years as well. So it's all sorts of paper, cellulose. It's been the insulation bit. And the reason we've been able to sell that to clients is because insulation isn't a huge capital cost of the building, is. And so these materials, if you've got the space within the wall section, they might be double or treble the price of normal insulation, but that's not a huge capital cost when it might be, the client might be spending £50,000 on a kitchen anyway. So so we've been able to use those materials quite successfully, but not just in posh houses, in school buildings, etc. But yeah, for me, it's the Mycelium that's really interesting. The insulation takes 3 days to grow, in effect, in a mold. So yeah, and the same, by the way, the same company have got we're doing a project where we're collecting food waste from a client's restaurant and they're using the fibers of food waste to create boards. So for me, we're on the cusp of something very exciting.
Brilliant. That's gives us all some hope, which is what we need at the moment. I mean, we know that we've got a big waste problem in the construction sector. That's a huge problem. Anything that we can do to address that is massive. So, Addy, I know that you've had some experience with this before, and I know that you've built a building local to me on the Wirral. Tell us a bit more about that, please, and how you came to do that.
Oh yeah, certainly. And I think on the topic of natural materials, it was about using engineered wood products for this particular project. And this particular engineered wood product was compressed wood. So fundamentally, because wood is a porous material, sometimes you can actually compress it. And by virtue of that, you can increase the mechanical property. So when we compress some of this wood, we were increasing like the Young's modulus by about a factor of 3. So which meant from a design perspective, you could technically use less material compared to if you had used the original material. So this project on the other side of Liverpool was built with compressed wood materials, not just as the beams and panels. We also used compressed wood as the connectors for the joints, which worked really well. And prior to even doing all of those things, a lot of tests were carried out. Like we had to investigate, for example, the fire resistance, the stiffness, the strength, because there's that issue with wood where you're often thinking of fire. How fire resistant is it? So it is. So this was carried out, and one of the key deliverables was to demonstrate that with this technology, you can eliminate, it's first of all, a sustainable technology, and you can eliminate some other materials like plastics and some other material, and then showcase this to the public, where I think anyone can actually go in, and it's currently being used as an office space. So you can go in and see how this technology behaves, and we're also currently monitoring how it will behave for the next 5 years, I believe, to see either if there are any deformations over time. So that's a pure example of using a natural material which is reasonably sustainable and eliminates other, well, non-sustainable material. So a quick overview.
Fantastic, thanks, Andy. David, do you want to tell us a little bit about what you're doing around the? I mean, obviously we've heard from Duncan, and interestingly, you know, I do know Biome. I've spoken to Ehab a few times. Quite an inspirational character, and he's doing some great work down there. You know, we wish him great continued success, because he's smashing barriers really well at the moment. So, but David, you know, I'd be interested to hear, you know, what you're doing with Miscanthus and how that's being developed now into the mainstream construction sector, and what your ambitions are for that.
Well, I mean, obviously we're very early days at the moment, and we're working with limited facilities. But I guess from our perspective, the way we look at it is that, one, we've got a natural material that's high yielding here in the UK. So we've got UK provenance. Obviously, the carbon miles are very much reduced. Because of that, we've obviously got the yield. But I'm very keen that because the actual crop itself is 48% carbon, I'm very keen that we trap as much of that virgin crop as possible without going through too many processes to increase its carbon output. So in terms of where I think we're moving within the construction side, we're hoping to produce some fiberboard, which will be carbon negative. Whether there's good uses outside of the office furniture side or not, I don't know. One of the risks for us is fire. Obviously, as Duncan mentioned, he's obviously got a good response for that one. But we see also that through the possibilities of biochar, that we can actually strengthen concrete. We've had some indications from Exeter that we can actually strengthen concrete through biochar within there, which in fact would be ideal, again, because obviously that's 100% carbon, or near as damn it 100% carbon. The miscrete, as I say, that's carbon negative. We've spoken to a couple of fairly large developers who thought that was quite interesting from the perspective of interior walls and things like that. So in their drive to reduce their total carbon footprint. In terms of plastic, we're obviously working on trying to produce the fibre to be suitable for packaging. We've done some work with another group where an organic silicate will make it hydrophobic, so therefore its credentials stay fairly secure, or we hope. I think the thing is, it's really, though, when you're looking at it from a plastic perspective, you really need to sort of come to the table and say, what can we do to reduce our requirements for plastic? So I mean, if we can take paper packaging or natural fiber-based packaging, what can we do to alleviate the downside in terms of, because obviously plastic has got strength in it, which a lot of people use for pallet wraps and things like that. Obviously it's a porous material, so we have to be very careful about that side of things. But I do believe that with a little bit of thought behind what we do, I mean, as you know, Neil, I've always said, you know, what we should do for every business decision, we should say, well, let's bring nature to the table. What can nature do, and what can nature provide? that will help us to solve this problem. Because even though sometimes one of the issues is, I think, is hidden costs. We don't look. We tend to look at everything as a financial cost, and hopefully now the FCA and the SEC are starting to move towards the whole ESG question and start saying, well, you can't just count it as a financial cost, because and I think you said the other day, there's this thing of unintended consequences. You bring something to the table, and actually, do you fully understand what those consequences will be for either new materials or existing materials? My take on it is that nature has been in the laboratory for more years than we can probably count, and it knows where it's going. It's able to evolve. And I think that the more we can do with natural fiber investigation and analysis, and the more we can do with creation of new materials. And from our perspective, obviously, because we are a renewable material that grows and actually is replaced every year, it's very fast growing. So we see this as maybe part of the answer to reducing our reliance on timber, because obviously trees take a long time to grow. They also take quite a while before they start capturing carbon properly. And I think I'm sort of saying, well, what can we do to displace the overuse of timber as well, and let timber actually work at providing our aesthetics and also providing our carbon capture and so on and so forth. So so I guess that's where we are at the moment.
Thank you, David. Tom, whereabouts are you in your journey, and where do you see these new materials coming through, and what sort of innovations have you found so far?
Yeah, I mean, well, it's an incredibly complicated challenge, as I'm sure we all appreciate, and it's fascinating to hear about some of these technologies from the other panelists today. And I've come across these versions of these in the past, and I think they are definitely going to be part of the solution to just reducing not only plastic consumption, but just having a more balanced industry in general. I guess at the end of the day, I mean, I'm always going to be a little bit biased. Well, I'll try not to be, but my previous project was obviously in glass fiber insulation. Now that is predominantly a plastic-free product. So in some sense, and insulation may be a bit more of a focus for this talk, I suppose. I'm noticing a bit of a theme, just because a lot of it is, well, there's room for a lot of innovation there, I think. And there's more options available. So it just lends itself to being able to move away from plastics in that sense. So just to throw some numbers, I think insulation use in Europe, we're using more than 8 million tons a year for Europe. And this is like a couple of years old figures. And more than 50% of that by volume is either glass, it's in mineral wool insulation. So this is your classic glass wool insulation and your stone wool. So this could be like rock wool, or your brands like Isover and things like this. And Superglass, who I worked with before, have a very small share of that market, or a part of a share in the UK especially. So we're going to have these, I guess it's inevitable, we're going to have these workhorse technologies that are going to pick up the bulk of these applications until these emerging technologies can really get a foothold and be scaled. So I'm curious about the Mycelium, for example, what the ability for that to be scaled up and sort of rolled out on a bigger scale would be, I guess, similar to the other panelists as well who have already spoken, Adi and David, like, is how long, what kind of timeline we're looking at here, so we can kind of get this staggered approach where we can potentially scale down a little bit, move a little bit away from plastic and to these other technologies. I think it's very challenging because so much of it is like a social problem in a way that you talk to people, and in general now there's been a very big push towards opinions changing away from plastics into alternative materials, which is great. But then when you put it into actual practice and you give people a materials option, say one's more, as soon as one is more convenient than the other, a lot of the time although they're saying one thing, they're doing something else, just out of convenience and sort of this autopilot. There's too many things going on. So I think it's, although the sustainable material innovations have to be also convenient and practical to use, I guess I would say. And I think that's why glass wool and mineral wool has had such a big uptake into the market so far, and that's great. And that's just something I think these technologies need to keep in mind. And I'm sure that they can overcome these challenges, and that would be great. Obviously, non-flammability and these other properties which they have that the plastics a lot of the time certainly don't is a really big selling point as well. A little bit like glass wool insulation does have some polymer component, and my previous project was about, traditionally these are made from petrochemicals like phenolic resins, which also release formaldehyde and VOCs. Moving away to more sustainable alternatives for these polymer resins, these binders. So this could be bio-based materials, it could be sugars. A lot of them are thermosets, but they're derived from bio feedstocks, and it's really good to see the industry moving in that direction. So hopefully I didn't talk too long, just a few thoughts from me.
Interesting, Tom. Duncan, did you put your hand up? Did you want to comment on that?
Yeah, one of the reasons for using the organic fleeces especially that we have is because of the ease of use on site, not having to wear a face mask where you might with other products. So yeah, I think that's something not to be underestimated. Yeah, I mean, we're talking about sustainability, we talk about well-being as well, and it's a big deal. I mean, I built my own house avoiding the use of plastic, and it was difficult. I'm not saying that, but one of the main reasons for that is for improvement of internal air quality, because we were getting, this is 20 years ago, we were getting a lot, and you still do now, getting a lot of super insulated plastic boxes basically, and the air quality, if the MVHR or whatever isn't quite doing its job, is not good. So for me, I don't find it too hard to sell for clients. What's really, I mean, it's got to be said out loud, what's been the challenge, I think that's what we're just saying, is the supply chain. Up until 2008, before that, the credit crunch, I was finding organic materials as a option to insulation easy to specify, and then they became a lot more expensive than standard insulation. And now that the market's smaller than it was 10 years ago, 15 years ago. So I think, meanwhile, you've got someone like Biome who've got 2 factories now, just about primed to start producing. So I think it's one of, I'm in the world of zero waste as well, and the circular economy, and working with people who've been in the industry for years, saying that 30 years ago the reuse of stuff was a lot more commonplace, and that old network's sort of dying back, but there's a new one emerging. So I think we're in that stage where things are dying back, but other things are coming through, and I am hoping that Mycelium will work well. One point about, I did put it in the chat, but I use a lot of locally sourced timber, and I'm in the southeast, and around London, we've got a lot of coppiced hornbeam and sweet chestnut. And if you're harvesting timber from a timber coppice, a woodland coppice, that root system might be 300 years old. So when you cut it back to the crown on a 25-year loop, it's acting as a carbon sink continually. So I don't think there's the pause, because the root system's so well established. So that's one of the benefits of coppicing. Yeah, that was my point.
Interesting.
Yeah, that's an interesting point, Duncan, because we're seeing now more information coming out about people building timber buildings now, coming away from steel and concrete. In New York, I think, announced recently they're going to build the first skyscraper with I don't know how many, 8 to 10 floors high, out of timber.
Well, they've done it in Norway already, but
yeah, that's right.
But yeah, New York.
How sustainable is that?
Well, it depends where you're getting your timber from, because if it's a management, the great thing about sweet chestnut, it's just win-win-win. If you manage those woodlands that were planted originally by the Romans brought sweet chestnut over. Then we used it in the Middle Ages to make charcoal and and to energize the iron industry. Yeah, these are working outdoor factories, the landscapes of factory. But if you're getting it locally, And the thing about coppices, what I was going to say is, if you work these human-made environments, it supports a greater level of biodiversity than if you leave them alone. The problem Sussex was happening. We've got tens of thousands of dying back, well, overgrown sweet chestnut coppices with 40-year-old stems, and the biodiverse environment was getting, well, the environment was getting less biodiverse. You work the environment, you get a greater level of biodiversity. So, wow, the thing we've got at the moment, which isn't a good thing, but it is, if you think of just what's local to you as a resource. So don't say, I've got people saying we only use hemp or something like that. What if there's no hemp on the market at the moment or whatever? So it's about a sensibility. It's not just saying I will only use hemp. That's why I was really interested in David's presentation, because he's working with all different sources and materials. You know, so sometimes there's different materials on the market. But for example, you know, straw, I did the first public straw building. But that's only because there was some straw we could use. You know, I've used mod cell and things like that. We're using straw. But if you want to roll that out nationally, the straw market's already sewn up. You're fighting over it with someone else. Again, that's why the elephant grass thing might be really interesting, because if you've got the land to grow it on, there isn't so much of a market for it at the moment. So you're not starving some other market of their resource, and that's what we've really got to think of, because there are
pretty much the definition of sustainability, right? Like,
yeah.
You know, it's got to be. We need to be able to keep regenerating it the right way we're using it. But I saw a sorry, Neil. There's a question in the chat from Leo. I don't know if you want to read that out, or is that not time for questions yet?
Yeah. So the question from Leo is, how can architects, designers and decision makers make better informed choices on sustainable alternative materials? What sources of information are already available to help decision makers in this process? Who wants to kick off with that? Hamish, you haven't said much so far. Is that something you want to comment on?
Well, yeah, I'll make a comment. I think it's lovely to hear about, you know, the fungi experiments with mycelium, the niche artisanal sweet chestnuts.
It's not niche.
It is niche by definition.
It is definitely niche at the moment.
Yeah, it is.
Definitely
the mycelium.
niche.
Watch the mycelium. You may mark.
No,
that's
I'm not
going to be
mocking
exponential. No, you're not. It might be
mocking
exponential growth. That would be.
Yeah.
What I'm not hearing from you, and this is the bit that I do want to open up the discussion on with respect to the designers and architects, is where's the yes and thinking? So I'm hearing you talk about lots of different alternatives going in different directions, and where they would be affordable and usable, and they would have an interested buyer who may have a point to make at their building or their construction methods. Great. But where's the yes and? So Duncan, your home, it's great that you set about making it plastic free.
Yeah.
I'm just wondering how that electricity gets into your computer to make sure we can talk to you today.
I didn't say I've solved every problem. I appreciate
so that's what I'm saying. I think I said
in what I know, what I said is in my expertise, where I'm in, I don't design computers, but what I've done, I think, is in where I've got responsibility in my work. That's where I've tried to do it. I think it's quite interesting, and for me, I think that's where the construction sector can be really impactful. I think we can have more impact in our work than we can in our sort of private lives. So, for example, I heard.
So my thought would be that we need, as a cross sector. You know, I'm coming into this as not a construction professional.
Yeah.
But in terms of cross sectoral thinking, I actually work in hemp in Germany for use in cosmetic ingredients, right? So I know that there's hemp fiber left over. Right now, I don't know exactly where it's going, but I can think of circular economy processes. They could actually make sure that by connecting people in a smarter way, we actually would be making every use of every last drop of natural resource that the planet provides us with. And this is why I'd be, instead of plastic alternatives, I'd really like to think about best choice materials depending on local market availability, local needs, and the opportunities that we can bring about. So I think we almost all need to move in a yes and mentality of saying we have to make the most of what we've got. It's even there's things like these novel organic materials, if they need the assistance of science, if they need the assistance of plastic to actually make them more durable, resistant to climatic effects, moisture, for example, then it befits us to actually work on those solutions as an integrated, synergistic approach, and not simply as, oh, well, let's make sure we get rid of everything we can that might be plastic. I think about the non-woven PPE membranes on my roof, keeping the water out, but allowing my building envelope to breathe. And I think we need that really engaged conversation amongst everyone that says, we're going to make the most of what the world supplies us with, and then drive that accordingly. And for example, just one other one of the things on bamboo that I loved was its subsoil sequestration potential. The problem was that the use of it in construction was so short-lived that you couldn't actually claim that carbon sequestration effect as, if you like, a carbon credit, because that particular use of that material would be over and done with in 5 to 10 years. Whereas I would really love to think about how we use organic, natural source materials, prolong the durability of them and extended life. If that involves using a bit of plastic on it, hey, let's consider that. As long as we design for end of life at the very outset, I think we can be very innovative scientists, construction engineers, and architects.
I was going to say, Hamish, thanks for that. I absolutely agree that, you know, we haven't got alternative solutions to some materials at the moment. I mean, we spoke with the Green Science Policy Institute in the States yesterday, and they're doing a lot of work around a lot of research around the use of PFAS. And that's extensively used within a lot of materials, and it's just starting to report now on the human impacts of PFAS as a you know, a chemical that's affecting us in all sorts of different ways. You know, so I think what we've got to do, the tide is turning, but I think what we've got to do is we've got to accept those materials in place now, because they are what they are, and that's all we've got. And if that keeps us warm and safe and so forth and so on, to a point. But I think we have to move towards more sustainable alternatives, and it's how we get to that point. I find personally that there's a lot of resistance from a cost perspective. That's the first barrier that I come across. And secondly, the other barriers I hear and find is the scalability, the access, the performance criteria, because most architects and designers will go to the MBS specification system, boom, pull it off that. We've spoken to Reba about that. They have got alternatives on there, but they're not, you know, they're not always as visible as you would like them to be. So, you know, I'd like to understand how we can move towards those alternatives, and, you know, how we can bring science and industry together to make that happen. Duncan.
Well, so one strategy I try and employ is around in this sort of concept of the circular economy, there is the biosphere and the tech sphere, and basically the organic and inorganic spheres. And I think, yeah, the reality is, I mean, at the moment, I would say is a number of organic insulation products that used to be 100% organic, and now, to improve their performance or ease of use or installation, they have plastic fibers or webs introduced into them. From my point of view, I understand why that's happened, but that's unfortunate, because you've mixed the biosphere and the tech sphere. So I would prefer to ask, because it's easy to do, to ask the high level question, which is, keep those two spheres apart, and just the challenge to the manufacturer and the design team is just to ask the question, what's the end of life strategy for that thing? Because if it's synthetic and never going to compost, then this is about corporate responsibility. The manufacturer of that thing should be the person that should be the organization receiving it at its end of life, because it's a resource for them. So if it's a complex material, relatively complex, it's an organic material with plastic fibers added to it, it's really difficult to deal with at this end of life strategy unless you've got a solution. So I think it's I think the designers of the world, they've got to step up to that challenge of understanding we've got to turn these linear systems into circular ones and deal with the end of life strategy and make the thing. How do you make the thing, whatever it is, a resource at the end of its life?
Okay.
Yeah.
Good point.
And sorry, I'm just going to jump on the question and follow up with some of the things the panelists have said, where the question was about getting information about that's already available there to try and essentially find alternative materials. And some of you might notice there's, for example, like the Granta EduPack, which is a database or framework that has different features. So currently, I think in the newer versions, there's a sustainability module, or I'll call it module, where with every material, there are different features there, like the embodied energy, the recyclability, and like Duncan said, the end of life feature. So what can you do afterwards? So a lot of these things happen in the design stage, and there are tools like the Granta EduPack that can help, for example, visualize or quantify the, let's say, embodied energy of all these different materials before making that can essentially helps influence that decision made. And it's not just Granta EduPack is what I've used. There's also something called I believe MathWeb. I don't use that all the time, but this is another example of a database that has different properties and sustainability features that designers and architects can use to make better decisions. Yeah.
Okay, brilliant. Thanks, Adi. So there's a question here from Leo. I'd like to open this out. I'm going to read this out to open to the panelists and see what the reaction is. What is the role of manufacturers in developing sustainable alternatives? And how should legislation in building regulations, etc., address the use of plastic within building materials? The Code of Construction Product Information, CCPI, will this help, and should it include plastic? So anyone would like to pick that up?
I'm happy to
have
a go. Well, just to take, it's also a little bit of a comment to the point we had before from Hamish as well. It's the one way that I interpret that is a little bit more like, yes, it's very easy to focus on specific products that we've worked with and everything, and that's all well and good and is going to help to solve the challenge. But we also need to take a look at the bigger picture as well, and in order to solve some of these challenges at scale. So, I mean, the industry in general is in somewhat of a, I mean, I know you, Neil, and the data paints a little bit of a scary picture when you look at it, in the sense that construction is the second biggest user of plastics. 20% of this 50 million tons is this huge output. But it has something it has going for it compared to the other industries, in a sense, is that if you look at the lifetime of these plastic products in their use in the construction sector versus other sectors, it's hugely greater. So you have, an average use, I think it's more than 20 years for plastics in the construction industry. So there's a much lower chance, or much lower, just because of how much longer that lifetime is, there's a much lower volume of that plastic that's going to be released in a negative way into the environment, for example, or for example, versus single-use packaging, or potentially. So that carbon is in use for longer, I guess, is what I'm trying to say. So there's some good things there. If we're trying to get towards addressing the problem, I mean, if we look, for example, to this legislation coming out next year on the plastic packaging tax. So there are some schemes beginning, or discussions coming into place in the UK, and that's going to follow in Europe and potentially globally as well. One of these is this plastic packaging tax, which says that if your plastic doesn't have at least 30% recycled content in it, it's going to be taxed at £200 per ton. So that's something that swings the balance a little bit, not necessarily away from plastics use, but it's turning off the tap of the virgin materials a little bit. It's turning off that petrochemical tap and helping push towards a more circular system. And a lot of the times we get businesses coming to us in the Sustainable Materials Innovation Hub and and they're like, what are these quick wins? What are the easiest quick wins that we can realistically make changes in our business and actually achieve? And one of the top of our list a lot of the time is source a plastic with recycled content in it, or look for alternatives that have recycled content in it, because it's immediately reducing the amount of virgin material coming into the market and creating a more circular system. So I think it's about, I mean, one of the big challenges in the construction industry, from my understanding of it, although I don't have anywhere near as much as some of the other panelists, is that there is a bit of a lack of data in general, just because of the nature of the sort of pop-up nature of a lot of these construction projects, and also the complexity with how the waste is a lot of the times aggregated together. So I think data is really important there to rank order where we can get the biggest gains with the smallest amount of work, the lowest hanging fruit, if you will, and we can use that to drive our decision-making process. I think that's really important, not just making these knee-jerk reactions based on a really small little view. It's trying to engage in events like this and becoming more informed, I think. So some thoughts there that hopefully useful to that question.
Yeah, that's really useful, Tom. Thank you. Does anybody else want to respond to that question, or Hamish?
Yeah, I'd just like to echo exactly what Tom was saying there, because the work that I've been doing looking at recycled content and reducing single-use plastic in packaging with the sort of food and beverage manufacturers that I tend to work with, more on the flavors and fragrances that go inside the products, not the actual plastic itself. But they face regulatory difficulties in terms of health and safety, and then aesthetics of increasing the recycled use. So I almost want to encourage the construction industry to be where plastic is the right material for all the things that Tom was talking about, extended lifetime of use, good viability in terms of performance versus alternatives, is to actually be much more married into the whole recycled reuse of plastic. Because I know that the technical strengths can be put back. The stuff I've been working on this year means that what plastic recycled, yes, it loses some of its technical performance parameters, but you can increase the level of additives by blending with virgin to actually bring back good performance. Now, if that means it's good performance but visually unattractive, then marrying the use of plastic in an appropriate way, designed for end of use lifetime with advanced recycling at the very end of it, can be another stream. I am all for, by the way, the natural use and byproduct use and helping farmers actually earn more money from using like the stubble that's there, or banana fibers. I work in bananas in Ecuador. Now, if we can actually get banana fiber to go into bioplastics and get it into other things, there's a huge amount of waste there. There is good, fast carbon growing and everything. So I just, Tom, I thought you taught an awful lot of sense there, and I was very pleased to hear it. And all of you actually, sorry, I'm a newcomer to this group, so I'm not, Duncan, I loved what you're saying. I may tease you about Mycelium, but I think it's brilliant. I think it's absolutely brilliant. And I think what we all need to be is inspirational in how we communicate about the good things that we can do, instead of good old Greta accusing everyone of going blah, 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 and activists really going blah, 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 and, verbally throwing up on people, let's put it bluntly.
There is a lot of alarmism, that's for sure.
We could be inspirational. When you get people being inspirational about solutions, and we're actually embracing multiple solutions, they do less harm to our planet. That's us actually moving towards genuine sustainability at scale.
Yeah.
And that would be my plea to everyone, no matter what you're doing and what you're working on.
I have to agree, Hamish, and with you, Tom. There's a lot of sense. You've all made a lot of sense today. It's been it's quite inspirational, actually. You're right. We're 8 billion people on the planet now, so naturally we're going to consume more. But in my view, we've really got to slow down consumerism. We've got to use less. We've got to work on using less. using what we've got, reusing what we've got. Recycling has a part to play in that. Circular economy is a big part of that process. In my view, and I'd like to, just as a final question, I'd like to open this up to the panel slightly. Recycling works in the way I see it, wood, metal, timber, paper. It doesn't work so well in plastic. So are we not just kicking a ball down the street? I'm not dismissing recycling as an option, but we understand now from the figures coming through that the amount of plastic that is recycled is quite low because the infrastructure isn't there on a national scale, on a global scale, and the labelling isn't there, and the understanding isn't there, and the education isn't there. So it's fraught with problems. And is that, unless we get the recycling process right, we're not going to get to the ideal point where you talk about where we can keep recycling it, because it's just going to end up on landfill or burnt for energy, and all that carbon released, or even worse, put in the ocean. So I'd like to open that up to the panel to see their views on that. Anybody want to comment? Go on, Duncan.
Well, Neil, you're right. We are choking on plastic at the moment, and it's that, you know, and I don't know if the statistics that came out yesterday around are alarmist around plastic, but we are choking on the stuff. We are physically full of it, etc., etc. So that, but you know, previous generations would have had their own waste streams that they were consuming. I think plastic's a wonderful material. I think we've got to design things for reuse. I've got this phone here. I don't know if you can see it. It's a Fairphone. Yeah? It comes with a screwdriver. It's just a different sensibility. So we're in a world of construction and the production of stuff. We've got to make sure that we reuse before we recycle, and that includes plastic. And if it hasn't been weakened by you know, by being in sunlight or whatever, if it's been built into a building, then that building must be seen as a material store for the future. When you unpack it, you reuse those plastic bits. And it's reuse before recycling. So you want to keep the sophisticated, you know, plastic's incredibly sophisticated, and you want to keep that level of sophistication. The last thing you want to do is shred it or melt it or whatever into something that's just a third-rate version of what it was before.
Yeah, I mean, one of the concerns that we hear a lot coming through is, and you mentioned it before, Duncan, health, well-being within a building. You designed your own house, and because of that, because we know plastic nanoparticles are in the air. We breathe plastic. We take it in through our lungs. It comes through our carpets. It comes through our cushions. It comes through our curtains. Soft fabrics in our house. You can't see it, but it comes in. And there's a report out in Newcastle University, Australia, that suggests, well, it concluded, peer-reviewed research, that on average, a human intakes 1 credit card of plastic per week. So, you know, that's worrying. So we have to really slow down the use of plastic. And I'm not sure whether the use of plastic in the long term is viable. I also bring into the equation the problem with fires and the release of toxic chemicals in fires, because we're hearing from California now, the firefighters are suffering, and all over the world. I mean, you've only got to look at Grenfell more recently in the UK. People are suffering from toxic inhalation, respiratory problems, etc., that's linked to the toxic chemicals that were released by those products. I'm not a chemist, so I'll open that out to the, you know, more privileged.
Put me on the spot.
Yeah. Well, you and Hamish, because Hamish is a chemist as well. So
the only thing I'd say, Neil, is that if we're consuming a credit card's worth of plastic every week, and we live for 70 years and maybe a bit more, we'd have about 12 kilos of plastic left in us. So either it's biodegrading inside our bodies, which everyone says it should take 1,000 years to biodegrade, or someone's actually just going for a little bit of headline effect with our consuming credit cards every week. If you think about it, we're managing to actually put stents inside people's bodies that actually keep their hearts alive that are plastic coated. You know, yes, we've had problems with people inappropriately using mesh inside people's bodies. So we do make mistakes with plastics for sure. But I think we need to avoid the alarmist stuff and avoid being sensationalist, because 47% of Pacific plastic patch is old fishing nets, and 80% of the other balance of it, according to the North Atlantic scientists, is made up of other marine debris. You know, I think we beat ourselves up about the wrong issues. The energy that's associated with waste plastic, that energy is the real killer, because that's a massive carbon footprint. So we do need to get recycling right. We do need to get reuse right. We certainly need to get design for proper sustainability right across all of our materials.
Thank you, Hamish. Right, we got final, just a little bit, last comment from everybody. Let's leave it on an optimistic note, and I'd like you all just to sort of make a comment of, you know, positive comments about how you see in the future, and give us some hope. So David, go on, over to you first. I'll put you on the spot.
Yeah, no problem. I guess my personal thing is that most of the arenas where plastics come from and so on and so forth come from finite resources. They may not be finite in our lifetime, but they will be finite in somebody's lifetime. So I think if we can concentrate on sustainability coming from renewability, at least we'll be heading down the right track.
Thank you. Tom?
Sure. I think it's been a great to be involved in this discussion. Obviously, it's not something we're going to be able to solve just today alone, but I mean, there's a lot of reason to be optimistic. Events like this, you know, creating shared resources, doing case studies, visiting sites, getting more of the community involved into these kind of challenges, you know, Dragon's Den type events. Some of the projects we've heard about today as well, all of this is part of the journey, I think, and there's probably going to be some legislation behind that a little bit as well, such what we've already discussed, this plastic packaging tax about recycling. Just to answer your point, it is challenging in a lot of cases, and part of that is about creating incentives to do it. It's creating the infrastructure to enable it to happen, having transparency, and I think in part, when you create awareness with the public as well, as we're already seeing, it becomes a driver, and so that's all. I think it's reason to be hopeful. I'll say that. I'll leave that as the message.
Thanks, Tom. Addy?
Oh, hi. Yeah, I think so.
Come on, Addy.
I love putting you on the spot.
Okay. So I would say, living here on a positive note, I think there's greater awareness, there's more education on this topic, and it's increasingly popular. And so I think that's a starting point. And so, like Tom said, we can't just solve it. So I think small incremental changes that we do will all have a combined effect. And so yeah, there was this. I have this deck of cards that actually have the properties of different materials, which I think hopefully can become a household card, but at least different factors that can be considered during the design stage. And I think all this does is, one, raises the awareness of different materials available and their sustainability. So we're knowing better, and I think it will get better. Thank you,
Addy. And Duncan, how would you like to?
A friend of mine got his PhD by producing a deck of cards that had all the. Is it now produced? He's rolled it out. I just thought Addy was just playing cards because we were getting boring. But look, when we built the waste house in 2015, it was finished in 2014. It was originally meant to just be a building that was using construction waste, just because for every 5 houses at the time we were throwing away 1 house worth of stuff. Halfway through the project, we decided to raise awareness of plastic waste because people weren't aware of it. Everyone's aware of it now. There might be, I agree, there might be a lot of alarmism out there, and there needs to be a bit of calm and understanding. But I just think it's an incredible time. This is the 3rd call of the day. I've got 2 more. You know, today, I've been in the world of sustainability for 25 years. I've been on my own for 24. You know, now everyone's having a go in a very well-informed way. And just every time I go on a call like this, I just learn something else. So it's such exciting, transformative times. But we do need to keep calm a bit. I mean, yeah, okay, there is a climate and ecological emergency, but we've got to do what humans do well and do something about it.
Yes. Thank you, Duncan. That was wonderful. Leo, do you want to say anything as a parting comment? Or?
Just very, very briefly, just a thanks to all the panelists this afternoon. It's been really, really enjoyable and really positive. And I think for me, the great thing is not just that we're talking about it, but I think, again, it's the whole social responsibility thing. So, if I think about COVID, what it's taught us is, again, that, we all have an impact on everybody else, and therefore the same thing in terms of materials that we use, the choices that we make, putting in our homes or our buildings, they all have an impact, not only for now, but also for the future, and also whether that's with regard to the circular economy and all that sort of side. I think it's again important that we, don't just talk from a marketing perspective. I'll put that back in there again. Good talk about build back better, but actually we actually do find ways to actually do things better in the way that we build and construct and design buildings and our lives around that as well. So thanks again for everybody for your input. It's really been great.
Yeah.
Thank you.
Yeah, mirror all those comments. So thank you, everyone. Thank you for joining us today, and your valuable time to participate in this. It's been a really enjoyable and insightful event, and I've thoroughly enjoyed it. I appreciated your input. So thank you very much, and we'll draw a line. That's kind of it, I think. So yeah, well done, everybody. Yeah.
Bye then. Good to meet everybody.
Thanks very much.
Good to meet you. Thanks, Duncan.
Bye.
Thanks, Tom. Thanks,
Thank you.
Thanks, David.
Ciao.